Good afternoon, everyone, and welcome to the Evolving Solutions Client Tech Talk webinar on storage automation. I appreciate you joining us today. I'm Michael Downs. I'm the Chief Technology Officer for Evolving Solutions, and I've got a great group of technical folks with me today to walk through a number of very interesting use cases in storage automation. I appreciate you being with us today. We've got the Q&A section is also available. If you've got questions during today's event, please feel free to post them there. I'll be watching the queue, as will some of the other presenters, and if we can answer your questions, we most certainly will. Otherwise, we're happy to get back to you as well. So there really are three use cases that I wanted to ask the team to cover today. One is talking a little bit more in detail about some automated discovery and administration using Python scripting, so sort of we'll call it basic because there's a lot that goes into these into the scripting work here for automation use cases, but it's sort of a constrained use case that we use. The second one is a little bit more detailed, using Ansible as an automation platform to extend an SQL database into public cloud. And then finally, we're going to get into even greater detail on some of the use cases that are possible using the APIs that many of the storage vendors are making available to their clients today. So most of you on the phone are clients, and I appreciate very much your being here today and spending time with us. So you may be familiar with us, but for those of you who aren't, Evolving Solutions is a technology solutions provider that helps our clients modernize and automate their mission-critical applications and support their business transformation. I think more importantly than that, we really talk about what our vision is for our clients as we see the challenges that they're facing doing business transformation. And there's one of the areas on this chart that I wanted to focus on today, and when many of our webinars have been focused on, is a section of modern operations. So modern operations is really our concept that many of our clients have asked about, which is how do I deal with all of these emerging technology concerns about cloud native and other ways of dealing with emerging demands from developers and emerging needs for business transformation that are continuing on now, regardless of what's going on in the rest of our world. And the other side, I've still got a legacy technology environment that I have to support, that I need to make more efficient, and nobody's providing us double the budget or double the staff to do that. So modern operations is really about the kinds of things that we can do around processes and people and technology that allow us to get the benefit of both worlds, things that allow us to both be better at what we've done traditionally in terms of our traditional environments, and that will also give us an advantage in a more cloud native, more distributed environment. So for example, today is a great example. We're talking in detail about automation and orchestration. So this is a great place where you'll see two things happen here. One is we have a cloud example for you, but also some of the work that we're doing to allow our clients and our technicians to do a more effective job of managing a legacy environment. So automation is just one of the key areas that help clients succeed in that modern operations space. So our presenters today are three of the folks that are on the technical team here and at Kiva. Kiva is an Evolving Solutions affiliate organization focused exclusively on orchestration and automation. And so our three presenters today are Rick Ketter. He's a solutions consultant here at Evolving Solutions and focused largely on large systems storage as well as other kinds of SAN deployments. Brad Johnson is a senior solutions architect with Kiva. And Brad is going to present some work that Kiva has done around APIs and automating storage platforms leveraging that RESTful API. And Jeff is a storage consultant with Evolving Solutions and specializing in a variety of technologies, and is going to share some of the work that he's done around the NetApp platform and Ansible. So I'm going to hand things over to Rick to walk through some of the work that he's done automating in Python.
All right. Just wanted to introduce myself again. I'm Rick Ketter. I am a storage and SAN consultant. Primarily my job is post-sale deployment assistance with customers. So if a customer purchases some new storage, I might be involved with helping to initially configure that storage and do data migrations from old storage to new, SAN migrations and deployments are a large part of what I do. So my talk is going to be based more from like a storage admin, just ways you might hack some scripting and stuff. It's really rough, and it's kind of just how I work. And I've tried to develop some of my own tools along the way here to make my repetitive tasks easier. So I just want to start with kind of where this came from. So I've seen a lot of storage admins have their own worksheets that make massive use of formulas. This one even uses macros, VBA scripting under the covers. And it works really well. I mean, what this is for a DS8000 PPRC, configuration. So I can put volumes in here and volume ranges, and then I have a storage matrix over here of what my source and target storage is, and all the ports that I'm using to connect those together. And so then when I create the scripts for this, it kicks out just a text file. And it gives me all the commands to make my paths and make the relationships, and it works really, really well. The problem with it as a consultant is I work with a lot of different customers, so I'm always maintaining different versions of this spreadsheet for the customers, because I need different volume ranges and stuff for each customer. And then the problem comes up is if I want to make an update to the script or the tool to make it a little more efficient, then I go into the macros under the covers and I change them and improve it. And then I look back and I have 10 different customers with an older version of this. And because the formulas and everything are built right into the worksheet, that's really hard to go back and then update the other customers' versions. So then I end up having to copy and paste data in and out. So what I really wanted to do was move the code out of the workbook and put it into something that's external from the workbook. I also have an example here of a zoning workbook here that I use, and I just have a kind of a control panel that I built here, and then I create my aliases for Fabric A here, and then zones for Fabric A, and then the same for Fabric B. I have aliases and zones. And then when I kick this one off, it creates script files right here for my alias and zones for each fabric. So I have Fabric A zoning and Fabric B zoning. I can come over here and I can toggle this to Cisco, and then if I were to put my vSANs in here, 12 and 13, kick that off. It's going to kick out the script files, and it's going to reload these here, and so now these are Cisco zoning. So it's really nice for me because I might work with a Brocade customer one day and Cisco the next day, and that's really nice. So these tools, they work. It's just getting to the point of extrapolating that into something that's not tied to the workbook. So I've been teaching myself Python. I'm not a Python expert by any means. It's been YouTube videos and learning and talking to people about it and stuff. So it's really just been a growing skill over time. And so those two workbooks I have, they work. I'm not trying to replace those immediately here. So what I am doing is making a tool for IBM flash system storage. It's a product that we sell, and it's based on SVC technology and V7000. If you've ever heard of that, that's built into that line. So what I did here is I just have, it's more of a simple workbook with different tabs here. So I have hosts, and then I have volumes, and then my fiber channel ports. I actually export this from the command line, and I get as a CSV, and I just import this in here so that I get all of my fiber channel ports. And then I define my SAN fabrics here and where my storage ports are on the SAN fabric. And then what I've done in Python, then I have the code over here in VS Code, is I have a tool that will go out and actually here I can show you my config file. So I can define my system name, the source workbook here, the Brocade, the SAN vendor if it's Brocade or Cisco, because this will actually create the zoning based on the hosts that I put into the tool. If it's Cisco, I need my vSANs. Here's the names of my zone sets. If the zone set is already existing for Brocade, I just I won't create a new one. And if I'm using device aliases or FC aliases, and so there's a bunch of different variables here. This is how the ports are grouped together for zoning. I won't go into the detail on that, but then when I run the tool, I'll show you here. It's just as easy as doing a Python /system tool.py, and it's just going to run and create these 3 files. And if I jump back over to the code here, I have my data directory here. My customer name is as our own company. I just put that in here, and then I have an output folder. So the output folder here, you can see the zoning commands. I had Brocade listed in the config file, so these are all formatted for Brocade. If I went back and changed that to Cisco, it would make these same commands for Cisco. So it's actually going to go out and create the aliases for all the hosts that I defined on that host tab, and then it'll create the storage aliases based on a storage tab or the fiber channel port tab in there. And then it'll actually go and zone the host to the storage. It's set up right now for single initiator, single target. I have plans to make some more options there for possibly smart zoning and single initiator, multiple target. And so this is really nice because it just kind of does all the thinking for me. All I have to do is go in here and set up what I want my host to be, and I import the fiber channel ports from the command line. So it should be a quick turnaround here to get zoning for a storage system into commands that I can just then send to my customers and have them run. I could go in there and tweak the the format of the alias and stuff if I wanted to, if it didn't conform to what the customer was using. And then this here is some of the commands that I would use to actually make the host on the storage system. So this is a make host command, the name of the host, and then the fiber channel ports, that worldwide port names for that host. And then it'll make the volumes here with sizes and the units, and it'll actually then map those volumes to either a host or a cluster based on what I have in my workbook. All right. Here on my volumes tab, I have the volume name Thor starting at volume 1, five of those. It's going to be 70 gigabytes, and it's mapped to the host Thor. Then the vCenter here, I have 3 volumes of 4 terabytes because these are for data stores, and it's mapped to the cluster vCenter. When I created my hosts, I have the host definitions here, and then if there is a cluster for it, I just put it in here, and if the cluster is blank, then it's not going to be mapping to a cluster. So that's kind of how I've been starting to replace some of my old spreadsheets that were really complex. I have a few minutes here. I wanted to show some of my discovery tools that I've created. For DS8000, I have a DSCLI script that I can send to a customer, and they can run this in DSCLI. And then they get an output file from that script, and they send it to me, and it looks like this. So you can see it actually has I/O ports in it. It has the DDMs. It has all sorts of information about the system. And if anyone's familiar with DS8000, there used to be a tool called DS8Q tool that was really nice in collecting some of this information, but it's not around anymore. So I built this to replace it. And this format, this is okay to find information, but I wanted it to be in a spreadsheet. So I have a tool here that I can run, and I just put the output of that DSCLI output. I put it into my input folder here for my customer. So I just take that file that I was showing you, the output file, and I put it into this DS8K input. And it's going to generate a spreadsheet, and it's going to put it in the output folder here when I run it. So Python DS8 query all. And so it's going to run a Python script. It'll go out to that input folder. It'll find the source file, and then it's going to build an Excel workbook with tables on every tab for the various components that it's finding in there. So this is pretty dynamic. If I decide to collect more commands, it'll just build more tables based on whatever commands I have. And then when I go to my output folder here, you actually see a spreadsheet or a workbook here actually. And when I open that up, give it a minute here to open. Come on, Excel, you can do it. Okay, so then actually has a table of contents with dynamic links to all the tabs down on the bottom. So if I wanted to, look at the show SI command, I can jump right to that. I can jump back to the table of contents. So Python did all this. I wrote this with modules that can interface right with Excel, and you can do dynamic stuff like this and create a really functional workbook using Python as the tool to do this. So these are full tables with filters on them, that are filterable, and you can fully functional workbook that's really nice. And then I could turn around and send this back to my customer and say, here's for your records, we have this. The last thing is I did the same thing for the IBM Flash system, but what I did differently here is IBM has an XML file that you can actually just download right from inside the Flash system. So if I search for cron, it's run in a cron tab every day, and it's an XML file that backs up the entire config. And I can download that and save it. And so I likewise just take that and I put it into my input folder for my Flash system input. And I have two of them in here, and actually the script will do every single file that I have in my input folder. So if I have a customer that sends me a whole bunch of different configs, I can put them all in here, and then I run my Flash system query all tool. Oops. And then that will just take that XML file. So I don't even have to send any commands to the customer to have them generate that. And it'll make basically the same kind of workbook based on that XML file right from the system. So I can get a nice snapshot of what the config looks like just by sending some simple instructions on how to download that XML file. So now you can see I have this Flash system query all here for done. Yep. So if I were to open up our SVC from our lab, same kind of thing. So I put the code level and cluster IP up here, and then I've got the same way to look at stuff in right here. So here's all the volumes that exist on there, fully filterable again. So that is it. I think I'm out of time, and that's kind of how I've been using Python in my daily workflow. So like I said, it's kind of rough, but it's really, really useful. And the more I learn it, the more efficient it becomes to just quickly turn around and write some stuff that I can interface with Excel.
Oh, that's fantastic. Just some really great, interesting work that you've done there, Rick. How long did it, as you're passing control back over here, how long did it take you to put together some of the scripts? You mentioned you're sort of doing some self-teaching and whatever else. How long have you been working with Python to sort of get to this point?
I have been trying it for a couple of years. I'd say within the last 2 years, maybe it's kind of been clicking. So it's kind of a thing where I'd go and take a course and you learn, what a dictionary is and stuff like that. And then 6 months later, you come back and you got to start over because you don't even remember how the basics work, right? So
Sure.
It's just digging in and finding an actual use case. I get bored when I'm making dictionaries of grocery lists or something, that you find in the examples online. So when I came up with my own use cases that I could use at work, then it really became something that I really wanted to dig into and learn. So I think that was the key, is just applying it to something that I needed and wanted to use. Obviously, it's taking, there's hundreds of hours into just doing what I did here unfortunately, I mean, that's just what it takes. But I think in the long run, for what I do for work, it's going to pay off and just being able to be more efficient down the road. So.
Awesome. Well, thanks, Rick. I really appreciate this. Some fantastic examples that you shared there. I'm going to actually ask the next conversation to get to a little bit different approach. So Rick really talked about Python specifically around some CLI commands, being able to use one of the things Python's great at is data manipulation. He gave us some great examples of being able to convert different data formats into better usable formats relating back to specifically the storage world. I'm going to ask Jeff to go into a little bit of detail on some work that he's done around doing a data refresh from on-premise to Azure using the Ansible framework. So Jeff, over to you.
Thanks, Michael. Nicely done, Rick. That was some pretty cool stuff. I'd like to say I have big shoes to follow, I guess. So where I started all of this journey in Ansible, it wasn't all that long ago, but I saw something on NetApp.io that talked about ONTAP select deployment using Ansible, and I kind of wanted to see what that looked like, see what it felt like, and found out along the way that, you know, Ansible can do a lot of other things as well, but the nice thing about that deployment was, you know, you have the ability to not only have a complete set of config, click the button, and it'll walk through. If you have an issue or an error, you can restart it at that point. So that was kind of the nice thing, where typically what we would have done in the past was we build out all of the ONTAP CLI commands to go ahead and, you know, issue command to change broadcast domain for this port, or, you know, create the LIF. You know, all of it's scriptable from a command line perspective, but, you know, everything is in sequential order, and potentially you might have to go back and undo something, or if one of the other options failed, you might have to do something different or take a different action. So it was really cool to learn that, and it was kind of something that led me to believe, okay, you know, there are other opportunities here to look at Ansible and the way it integrates with not only NetApp, but also the different servers that might be out in the environment. So in my brainchild here, all I did was I created an on-prem SQL server, created a volume with 3 LUNs in it, and, you know, wanted to see, you know, the workflow and how to make it work to get the data from on-prem out to Azure using NetApp, SnapMirror, and iSCSI LUNs, just to get the data across from side to side. There's obviously a little bit more feature-rich options. You know, in my scenario, I end up stopping SQL just to make sure we get a good copy of SQL on the front end. But you could use a tool like Snap Center or Snap Manager for SQL on the on-prem side, just to make sure you don't have to stop SQL. You're not really impacting the user at that point either. But in the process here, I'm injecting a row in my refresh table to say I'm taking a refresh at X time, so I'm issuing a SQL command at that point. I'm stopping SQL services on the server. I am taking the NetApp snapshots that exists, because in my scenario as it exists right now, I already have a refreshed environment sitting out in Azure. So I need to clean that up. I need to then take that snapshot of the existing data, replicate it across, bring it back online on the Azure side, and all of this is done through the workflow on the Ansible host there. So I'll take you through my example here. I'll show you what I'm talking about, keep me honest with the row that I'm entering in the table, and yeah, if you have any questions afterwards, let me know.
Well, just bringing up this screen, just a reminder that if you do have questions, please post them in the Q&A. I know the team would be happy to answer anything that you might have questions about. So.
All right, just another keeping me honest thing. I have a on-prem ONTAP select instance, one of the ones that I built out using the Ansible deployment. And then I have a Azure-based Cloud Volumes ONTAP instance, single node. So that's not an HA in that config. But if you look at the replication I have in place here, you can see that this D2 SQL demo goes to a targeted a mirror volume on the Cloud Volumes ONTAP instance. So I'll go ahead and kick off the playbook here, and you'll kind of watch as the SQL instance gets taken offline. after it, or sorry, apologies, on D3 side, it'll take it offline. We'll refresh this just to make sure it's doing what I said it did, and injected that time stamp into the on-prem side. It stopped the services. Now you can see it's kind of going through the disk removal process, taking them offline, and then it's going to disconnect iSCSI on the target side. So it's working through both operating systems right now, and now it's going to go jump back into the NetApp side. So it's going to hop back and forth between both NetApp and the operating systems up until it's ready to bring the database back online. So I think a couple places where I could certainly benefit from a little bit more time here is I just built in timeouts. So I put in 15-second timers for these things to get updated, but an actual query to make sure that the snapshot's been removed, the mirror's been updated, that it can see the snapshot, the new snapshot on the other side. Those types of little functions and features I think would be nice as I kind of develop this a little bit further. So now that the snapshot has been replicated across to Azure, it's going to create the clone. Now you're going to start to see LUNs come back online and drives being mapped.
Jeff, what would happen if those weren't removed and stuff when they were supposed to be?
Well, you'll get failures along the way. So if a snap mirror or a snapshot exists already with that particular name, you're not going to be able to get it updated. So those are little tweaks along the way that I've found having to clean up ahead of time is much more, it cleans up the process on the front end. So now we've completed the script. The SQL service on production has been started. And then on the Azure side, we can see that the database now exists here, and it's just running. So you can see I've got some entries there, and here. I'll run that guy too. So you can see we're matching here, and the most recent one is the highest incremented number here too, but you can see the timestamp of 1027 on both of these. So you can see that the data was replicated from side A to side B. Now, the use cases are in this instance, if you need a reporting instance out in Azure, you've already got the data on NetApp, you can get it out there in a fairly quick amount of time. You don't need to completely re-inject all the data. Dev test environment, right? You need to get a new thing spun up and ready to go. It's real quick, at least from the NetApp side, the data's already there. All you need to do is point something at it to use it. Or if you're going to actually do a migration out into Azure, those are at least a few, and the same process, slightly different commands obviously will work for AWS as well. And another thing I wanted to bring up here about the way just the storage modules that Ansible can take advantage of here. So I mean, you've got EMC, you got some IBM, but NetApp has a lot of integration points. Keep in mind here that it has E-Series, it has your SolidFire or even your HCI storage nodes there you can do this with, as well as the ONTAP. Pure, I believe, is available here as well too. So all of those platforms have quite, or at least the NetApp and Pure side, have quite a deep integration with the Ansible side as well. And then let's say you find the cure to coronavirus and you want to bring it back on site to actually do something with. There is the ability to, because you're on NetApp, you have the ability to replicate that data back. And Cloud Manager here, they try to make it cloudy. So they've made a drag and drop option just to get replication back in place. So you don't need to necessarily have all the commands that you need to know on the front end to get the volume created on the destination side and the relationship establishment. Now, essentially, you just literally drag and drop, and you've got the ability to select your destination volume. Looks like it hasn't updated with the newest volume that was just created, but you can just drag it here, select your target, select your information you want to store on the destination side, bring the data back, and then you've got the ability to migrate between clouds or migrate data back we've heard that's been a struggle for a few different clients along the way.
So I think part of what it sounds like the value for Ansible in this particular case is you're touching quite a few things. You're touching SQL, you're touching operating system, you're touching NetApp, you're touching a variety of things that need to be synchronized or sequenced.
Yeah, and as well, I mean, if you needed to, I'm actually not only doing stuff on the server side, but I'm injecting information into SQL along the way too. So you can run
Sure.
native SQL commands. Not only are you doing a lot of native commands with your Ansible piece, but you have the ability to, if you have a more complex PowerShell script, right, you can run that too directly from Ansible to get everything you need to get done from there.
Awesome. If you want to pass the presenter back to me, we'll go to the next set of questions here. Again, if you've got questions or comments or things like that to the team, please feel free to pop them in the Q&A, and I'll be happy to pass them on to the team. Yeah, I think that's a fantastic example of why you might pick a platform over just a scripting language. And so I appreciate you sharing that, Jeff. Great example. And I am now going to pass on to Mr. Brad Johnson, who is part of the Kiva team. Kiva is an affiliate company of Evolving Solutions, and they do quite a bit of work with APIs and integration. Brad has written a lot of, including Ansible modules using Python. So I wanted to ask him to dive in a little bit on using APIs for automation in the storage space.
Yeah, so first, when we talk about doing automation of storage systems, right, there's kind of like three different flavors. You have, your base CLIs that you use to interact with these storage systems. You can automate those. Then you have, things like Ansible, where the company that provides the storage might have already developed modules that you can use, or maybe you're calling some scripts through that. But then the final case is that, you're actually using storage APIs to interact with the systems. And, the reason you might want to do that is just having a lot more control over the whole process of exactly what you want to automate. When you talk about just scripting a CLI, you're not going to be able to get data back quite easily. You can read return codes, but then you're often talking about parsing text. When you use Ansible, it's absolutely a great automation tool. But it does have a couple drawbacks in that, you're using these pre-built Python modules that are designed for specific tasks, and they might not exactly fit your organization. If Ansible can fit your use case, you should absolutely use that or another similar tool. But if you have a more advanced use case where speed or customizability or custom interaction with multiple systems is your target, then that's when you want to start looking at using an API like a REST API or an SDK provided by the storage vendor. These are cases where, say I wanted to, we had a demo recently with a customer for a Cumulo system. They're a REST API first storage system. And their whole system, they wanted to create 21,000 shares. And that would take a while to do that through Ansible because it would have to churn through them serial one by one. But just doing this natively in Python with the REST API, I could thread this out and have 50 threads calling the REST API at the same time. I could even have those, spread out to multiple nodes of the cluster because there's multiple masters in these systems. If you didn't have a load balancer there, you wanted to target them individually. Also, this can be used to then, develop new functionality that might not already be there. Say we wanted to monitor two clusters and handle failover between them, and the vendor doesn't provide a tool to do that. We could create a tool like that that would, monitor for different conditions across these and look at that, and then, trigger failover based on those or restore if healthy. That's a feature that might not exist, but, we're able to create it. And, when you think about just, doing something with Ansible, it might, check for the state of something. If it exists, update it. If it doesn't exist, create it and do that desired state configuration. But you might not need all those operations. And if you're talking about a really high volume, you might want to just get the properties of something without doing a lot of additional information, or you might want to interact with an outside database system like a configuration management database or another source of truth where you just want to take something like your CMDB and then apply that into another environment. With a scripting language like Python, you're able to go and actually do everything with the full power of a programming language. So if you wanted to pull information from a database, update a storage system, send a Slack notification, you could do that all in one item. And also, using a REST API, you could even build a module in Python that would be an Ansible module, which would then allow you to have, repeat functionality of what you built in a more standard interface for people in the organization, maybe admins or operators. So there's quite a bit more you can do, but it really does require that you evaluate the use case. Another thing is that not every storage vendor's API is the same or equal in documentation or support. So this is something you want to evaluate when you look at it. And this is really a place where somebody like us at Kiva can come in and help and do the heavy lifting and maybe build an Ansible module, build an integration or feature where it might be something that can significantly help your workflow. So a couple of the drawbacks like I have on the board there is it's really going to depend how experienced a developer is in making something like this. If you're good with REST APIs and good with Python and Ansible, it can be a pretty quick turnaround time. But if you're not quite as experienced, then it really helps to bring in somebody like us who can just help you develop that. And yeah, I think that pretty much covers where we would want to use something like this. So go ahead, Mike.
Brad, I had a quick question for you. So I know Kiva does quite a bit of work with CICD as well. Is there any kind of advantage for any of these approaches, either sort of base script or Ansible or using a RESTful API when it comes to integrating storage or potentially storage provisioning capabilities into a DevOps site?
Yeah, we could, build something that would listen to a CICD pipelines, trigger, upon completion, or it could trigger a CICD pipeline. It's all like depends on the use case of what you're looking for. One of the things about using the API is that it gives you this low-level access to what the storage system can do, and that means that instead of accessing more like a function at a large scale, you can access individual features within it, so that you can execute like single parts of the code, because when they develop the APIs, they're usually representing the individual pieces that they themselves use to create larger functions. So absolutely, we could interact with the CI/CD pipeline. I'm not sure exactly a specific use case offhand I could bring up for that, but.
Okay, yeah, I was just curious. I mean, I know that like we've talked today about sort of scripting, about Ansible, about the REST API, and if there were any advantages or disadvantages from a DevOps perspective to any of those, or it's sort of pick your poison depending on what it is you're trying to accomplish.
So with the APIs, again, I think the use case here is where you want to do something more specific or with higher performance.
Okay.
I think that's the best, or the feature doesn't already exist. That's the best use case for automation with APIs and that lower level. If you can find an Ansible module and you don't have a performance issue with that, then absolutely. But if you're talking about hitting an API tens of thousands of times in a short amount of time, then it's better to use a programming language like Python or Java to do that. Whereas like with Ansible, you can still use Ansible to call an API, but you have the overhead of the system behind it running. So
awesome, thank you.
There's one more slide on here.
There we go.
Yeah, I kind of touched on this as well. It's this type of situations where maybe the administrators or the people that are more of a traditional background don't have the experience with doing APIs or Python or development. This is an area we can come in and work with the people that are in these roles across our customers and help them develop these tools and functionality that we could put them into an Ansible playbook, or we could create a daemon that's running and consuming API calls and making other API calls, right? Via CICD pipeline coming in, via connections to a database, and really take something that could make your life better and faster, and consume that and turn it into a more simple block of work, right? A Python program you could consume, even a command line tool with arguments we could create. So yeah, I think that covers it pretty well.
All right. Well, thank you, Brad. I really appreciate it.
Yeah, thank you.
And I thank you, everyone, for joining us today. We've done a number of these over the last couple of months, and I've really enjoyed hosting them. Thanks to everyone on our technical team inside of Evolving Solutions who's participated. It's been a lot of fun, and we are going to resume these sort of more technical client talks probably in September. But next month, we have a really exciting event starting. We're going virtual for our 2020 technology update this year. So we're doing a webinar series beginning in July. As you can see, the first one of these is Jamie Gamach, the CEO of both Evolving Solutions and Kiva, is going to provide a really fantastic update on sort of the state of the industry, his perspective on where things are going, and how we're all working together. And then culminating on the end of July, we've got a speaker from IDC who's going to join us, who's going to have a really broad perspective on enterprise infrastructure, cloud, and has a really good perspective on how COVID and some of the current situation that's happening in the rest of our world is impacting IT and our ability to recover. So I hope you'll join us for that. We look forward to having you. Thank you all for joining with us today. You should receive an email in a couple days with a link to the replay and a short survey, I think right after this. If you could provide us with some feedback on the value of this for you guys, we would really appreciate it. We look forward to making these as meaningful for you as possible. And I look forward to seeing you all again in the near future. Thank you for joining us today.